Color is something that has always fascinated me as an artist, and one topic I find incredibly interesting is how we see color, like the science behind it and how our brains go about perceiving it. And one thing I think perfectly represents the interesting nature of this topic is the color magenta, and how it's not real, per se. Which, if you didn't know that by now, sorry to break it to you. Okay, but what do I mean by this? Because physically you can see it, so how is magenta not real? Well, essentially, the long and short of it is our brains make it up. So how does that work? Alright, to explain, we first need a light source. Now, light has all the colors we can see in the visible spectrum of light, so when it strikes an object, let's take this apple for example, the apple then gets to decide what colors to absorb and what to reflect. When that reflected light goes into your eyes, it then hits your retina, which are comprised of photoreceptors called rods and cones. And for the purposes of this explanation, we only need to worry about the cones since they're the ones actually responsible for color vision. Now, there are three types of cones sensitive to short, medium, and long wavelengths of light. To simplify, we can picture these as blue, green, and red, which correspond to the visible spectrum. Now, going back to that apple from before, the red light that's reflected off of it will hit your eyes. It will then trigger your red cones, which will send a signal to your brain to then perceive the apple red. Now, let's switch out that apple with a rubber duck. Well, on the visible spectrum, yellow falls in between red and green, so that yellow light will trigger red and green cones simultaneously, sending a signal to the brain to perceive yellow. All makes sense? Great. So how does magenta fit into all this? Well, the astute of you will have noticed that magenta does not exist within the visible spectrum. So here's the dilemma. Magenta is the result of the signal by both red and blue cones being triggered simultaneously. But if we look at the visible spectrum, what falls in between red and blue? Green. And the green cone isn't being triggered at this time. This is the problem, so to speak, because our brains don't really follow this spectrum exactly. What I mean by this is our brains want to take this linear model and make it cyclical, which is to say it wants it to be a color wheel of sorts. And so it achieves this by creating a placeholder color it can put at the ends of the spectrum to connect to them. This is largely what magenta is. It's simply just a color that our brains create when they perceive red and blue light simultaneously without any green light present. I hope all that made sense. I'm not entirely sure how to conclude this, so thanks for listening. And I hope you were able to take at least something away from this, or maybe learn something at that, I don't know.